Today we're going to be talking about Chapter 4, Section 2, which is cautions about correlation and regression. So the first thing you have to know is that correlation and regression describe only linear relationships. So when you have data that's fairly linear, you can use correlation and regression. However, the correlation R and the least square regression line are not resistant, which means that points such as outliers or significant influential points can adjust this least square regression line and cause it to change.
Extrapolation is the use of a regression line for prediction far outside the domain of values of the explanatory variable that you use to obtain the line. For example, a graph of U.S. cars in 1920 and throughout 2013. However, the data is only up to here. So the rest of the line is used to, so the line of regression is used to extrapolate to the point 2013. However, the use of extrapolation must be done with a lot of caution, because even though this line says that the number of cars in the U.S. in 2013 is supposed to be about here, the real number of cars in 2013 in the U.S. is here, because not all relationships are linear, and therefore we can't just extrapolate. Lurking variable. A variable that is not among the explanatory or response variables and yet may influence the interpretation of relationships among those variables. One example is the association between SAT scores and college GPAs. Does this mean that having high SAT scores cause higher college GPAs, or that higher college GPAs cause higher SAT scores? No. This is because there is a lurking variable, intelligence, that determines both your SAT scores and your college GPAs. The next thing you should be wary of is average data, because correlations based on averages are usually too high when applied to individuals. This is because the averages smooth out the variations.
There are three examples of association. The first one is called causation, and the diagram looks like this. One example of causation would be smoking and cancer. Smoking cigarettes would cause cancer, so that's what X and Y stand for. The second type of association is called common response, and the diagram looks like this. One example would be ice cream sales and drowning. But does ice cream sales cause drowning? No. A lurking variable which causes both of these would be summer. So summer causes an increase in ice cream sales, and it also causes an increase in rates of drowning.
The third type of association is confounding. The diagram of this looks like this. One example of this was a study that found that bringing tea to elderly retirement homes made the residents more happy. However, the study concluded that tea does not cause happiness. It is actually the third lurking variable of social interaction with the college students that made the elderly retirement residents happier. Causation. The only way to prove causation is through a well-designed experiment. See, that was pretty easy. I hope you learned a lot.